Hi, kids. I am gonna keep talking about photoelectric effect, and we're also gonna talk about how to interpret the graphs a little bit, how to find maximum kinetic energy, that stuff. So let's just as a quick reminder with photoelectric effect, remember you have something that looks like this, where this is a metal. Okay. You start with a photon coming along and it's going to hit the metal. As long as the photon has a high enough frequency, you're going to knock an electron off, and that electron is going to be moving, which means it has kinetic energy. And then you can do stuff like, hey, power a calculator or whatever. But with that. And actually, I want to talk to you guys a little bit about this as well, because you do this as well, where it's like, hey, if I hook this up to, actually, I'd want it to be negative on this side. Okay, if I hook this up to a variable voltage source, and I was trying to solve stuff, you can also do a little bit more with the energy, so we'll talk about that too. We'll talk about what your graph looks like, all that other fun stuff, okay? But so remember, guys, conservation of energy. So if you step this through, you start with your photon's energy, h times f, okay? Some of that energy gets used up by the work function, so you need some energy to knock that electron off, and then whatever you're left over with is your kinetic energy. Now, if there's an equation where it's like, hey, solve for the speed of the electron, you could do 1/2 mv squared. But just remember, if you're doing it that way, everything needs to be in joules, not electron volts. But to convert from one to the other, it's easy. Look on your formula sheet, no problem. But let's say you had a problem where it was like this. If you had a problem like this, then this kinetic energy as it moves over, because this plate is going to have a negative charge, as it moves over, it's going to turn into potential energy. So you could say this is equal to your potential energy. The potential energy is going to be Q times delta V. So you could figure out, you could adjust the voltage, and then if this thing goes all the way and then comes back, if you know what that voltage is, you know what the change in voltage is for that electron, you know the charge of an electron, you could solve for this, and then if you knew this, you could solve for this, all kinds of other stuff. But that's kind of the basic, a little bit more with the energy. But if I go back to this graph, where remember this is really your maximum. If I go back to this graph, a lot of times you're going to see a graph that looks like this, where if I graph the maximum kinetic over here, and I graph frequency on this, that you're going to get a graph that's going to look something like this. Okay. Now the reason it looks like this, okay, is that there is a certain frequency you need in order to knock the electrons off the metal. Okay, well, what is that frequency? That would be when, hang on one second. Nope. All right, better. Now you can actually see it. Sorry about the glare. That frequency would be called the cutoff frequency, or maybe it's called the threshold frequency. It's not really important, the name of it, but there is a frequency that you need in order to just knock an electron off. That would be like, hey, this minus this equals 0. Okay, so I've just barely knocked an electron off. Okay, but it's not moving. It didn't have any leftover kinetic energy. If I was to do this, a lot of times you'll see this is dotted. That's supposed to be a straight line. The reason it's dotted is, well, you can't have something with a negative kinetic energy. Like if I have a photon that doesn't have enough energy to overcome this, well, what's going to happen is it just gets absorbed and it doesn't have enough energy, so the electron doesn't get knocked off, okay? Which is why it's down here. But this value, okay, and that should make sense. If this is 0, then that value would tell you, okay, that would help you find the work function. Okay, that would help you find the work function. And then the other thing, hopefully it makes sense, your slope is going to be equal to Planck's constant. Yeah, I'm not really sure there's that much else to talk about. But yeah, I guess one more thing to talk about would be this. Let's say I had 10 to the 15th hertz, okay, right here. And we will say that this value is, I don't know, I'm going to make up something, 4 electron volts. So that value right there is 4 electron volts. So if I had a frequency that is here, okay, well that frequency would allow you to have a maximum kinetic energy more than 4, but remember, this is the max. So anything, so let's say this was like 6 eV for my maximum kinetic energy. I could have, if I was at this frequency, I could have 6, but I could also have anything less than 6 for an allowed value. So I think that's everything. All right, bye kids.